Hello and welcome to Rich's Garage. Today we're going to make a cheap benchtop power supply out of an old computer power supply. So the nice thing about these is, one, they're very capable in terms of their output, and two, it's really simple if you've got an old one lying about. If you're not comfortable messing about with electricity or things like this, please don't. This is just the way I've done it and it works for me. Have you ever found yourself in need of a cheap but capable 12 volt or 5 volt power supply? Well, I give to you the computer power supply. This is out of a small form factor computer that someone gave me because it was ready for the tip, but you know, I like to keep hold of these things. So if we have a look on here, we can see that the DC output, well, we've got 3.3 volts, 5 volts and 12 volt DC. They're all I'm really interested in at the moment. So at 3.3 volts, this power supply here can pop out 28 amps. At 5 volts, it can pop out 35 amps. And at 12 volts, it can pop out 24 amps. So this could be a really useful benchtop power supply. So what I particularly use this one for is actually my model railway. But you could use it for anything. I've used it in the past for industrial Ethernet switches. Let's show you what you can do. So on these ATX connectors, you have typically, or way back when, you had 20 pins. These days you have 24, or in this case you can split it to be 20 or 4, and you will find a green and a black wire next to each other. If you short those out, as you can see I used to do rather unreliably with these wires, you will cause the power supply to come on. Because typically, if those wires aren't connected, the unit won't power on until it receives a relevant signal from the motherboard of the PC. But if we short them out, either temporarily with a little jumper wire, or as this power supply serves no purpose to me anymore really in a PC, I just decided to cut those two wires and bridge them together with a, not a Vargo connector, but a cheap version of a Vargo connector, shall we say. And then on all of the, I can't remember what they're called, not the SATA power leads, the legacy power leads that you find for things like CD writers and old hard drives. You've got typically a set of 4 wires that come off there. So you'll have 2 blacks, a yellow and a red. So the black wires are your ground wires. So all of these are terminated in a Vargo connector, because when I power it up I don't want them to short out by accidentally touching each other. Plus they're also useful for connecting to your devices. You can just feed your wire in there and off you go. So now that we've got these, I've got my trusty multimeter here. I'm going to pop it to DC, and we're going to actually trap it in the Vargo connector there. So black and yellow, if I remember, produces 12 volts. So we've got those there. Let's fire it up. So just standard lead that you'd plug in a PC with. Pop that in there. Pop that into the plug. And there we have it. Yellow and black makes us 12 volts, as we can see on our multimeter. So I'm going to take that out of the yellow one, probably switch it off before we do this, and then pop it into the red one. And there we go. We've got 5 volts. So you can use these to power anything. There we go. Really nice, cheap little benchtop power supply. What else have I used them in the past for? Oh yes, back in university days I used it for powering a car head unit and a car amp to make a portable sort of boombox system. God, the things that we do. This is going to go back to the model railway for now, but yeah, 5 volts, or let's go back to the yellow, 12 volts. I have actually got a video or a photo somewhere where you can measure the amperage of what you pull in. So so what you need to do if you want to do that, I'm just going to unplug that. So to measure the amperage of something, what you can do is you can pop. So I could put that into my device and then put this in line with the device, and it will measure the amperage. If you were to go to the amperage setting, I'll see if I can find something to test that on. Right, so what we have here is our homemade benchtop power supply. We have our connection, so our yellow and black going into a cigarette lighter socket, or I don't know what you call them, a 12-volt car DC socket. This is one I made many moons ago for something, I can't remember what. Now this isn't a very good usage of this, because what I've also got here is a really old inverter, but it's what I've got that I can do a demo with here. So so we're going to go into our PC power supply, come out at 12 volts, into our cigarette lighter, and then into our inverter. And then what we're going to plug into our inverter is just a drill charger and with a battery on it, because that's what I happen to have laying about. So let's pop that. Let's turn on the power supply by plugging that in there. There we go. That little beep is just us, the inverter, telling us it's alive. So we have got green light on the inverter, which means we're getting 12 volts power. Excellent. And then we're going to plug in our battery charger. Hear the fan spinning up in the inverter, and we've got ourselves a charger light on there. So if I was to leave that, then it would charge the battery. But what I'm keen on doing now is actually measuring the amperage that this setup is pulling. So I'm looking at this, and this has an output of 1500 milliamps. So let's have a look, see what, use the multimeter to measure the amps. So what have we got here then? So with the multimeter, I have had to move my positive connection there to the outlet there that says A on it, because that is fused for up to 10 amps. So we pop that on there, and we've also got it set to the amp setting. So my multimeter will do DC amps or AC amps automatically. We've got the battery charger. I'll put that on the end there, so we know that that's the destination. We've got the inverter here plugged into its cigarette lighter socket, and so if we trace those wires, so the 12 volt positive from the power supply is going in to the unit. The negative is going into the input of the multimeter, and then the negative from the multimeter is going back into the power supply. So if we turn this on here by plugging that in, the inverter is alive, the battery is on charge, and we can see on our multimeter there we are drawing approximately 2 amps. So there we go. That's how you measure the current in use on a circuit there. Yeah, excellent. So according to this power supply, it could actually deliver up to 24 amps. I'd just like to say again, you know, this is the way I do things on the channel. I know what I'm doing, because I've been doing it for years. If you don't feel comfortable doing it, please don't do it. So happy days. I think I can take that battery off charge, because I don't really need it charging, and that's a very inefficient way of doing it. Right, I might have found a bit more of a practical use for my contraption. So let's see what we can do here. So PC power supply, multimeter connected in line with the device. So this device is expecting what's it expecting? 11 to 18 volts. And I'm pretty sure the amperage very much determines on the output you want to put into a battery. So let's pop that in there. I have to apologise, when this charger fires up it's got a little bit of a loud fan in there. So coming out there, let's pop it in. You never know, you might find yourself in a bit of a disaster. Can't find something like this, but you got one of those knocking about. There we go. So I think we should probably find a battery to pop on it. So pop that battery onto there, the right way round. So this is, how many milliamps is this? So this is only 800, so we'll only be charging at we won't be charging at that voltage. Sorry, at that ampage. Right, be interesting to see what the multimeter says. So it's checking 2 and 2, excellent. So it tells us we're popping in 0.8 amps. Actually, it looks like we're drawing roughly 0.7. So excellent. There we go. I've just given myself an idea now. I could have one power supply like this that feeds multiple ones of these. I think that's going to be a project for another day. Right, I might leave that to do its thing. Excellent. Thank you for watching. If you enjoyed that video, hit the like and subscribe button for more useful tips in the future.